Hey, and welcome to this lesson on consecutive angles. The essential questions for this lesson: what are consecutive interior angles and what are consecutive exterior angles? And by the end of the lesson, you should be able to understand the relationship of intersecting lines and the angles formed when the lines are cut by a transversal. Just a little review from the previous lesson. Remember that 8 angles are formed by the transversal. We're going to be looking at this situation a lot over the next couple of weeks, and this is probably the most common situation of intersecting lines that you will talk about in math class, of all the different angles and theorems that are formed because of this situation. Remember right here, this line that cuts across the two lines, it's called a transversal line. And backwards, M may or may not be parallel. And so last lesson we learned about angle pairs and how to use those angle pairs to determine if those two lines are parallel. We talked about alternate interior angles, which for example would be the angle pair angle 5 and angle 3 right here would be alternate interior. And we said if line M is parallel to line N, then angle 5 is congruent to angle 3. And that theorem, the alternate interior angle theorem, that converse of that theorem is also true, meaning that we can prove that that line M and line N are in fact parallel by proving that angle 5 and angle 3 are congruent. So it's just as true to say that if angle 5 and angle 3 are congruent, because of the alternate interior angle theorem, or the converse of the alternate interior angle theorem, then lines M and N must be parallel. Now we also talked about alternate exterior angles, and the alternate exterior angle theorem was very similar. It stated that, well, first, let's mark a pair of alternate exterior angles, angle 1 and 7. Previous lesson talked about the alternate exterior angle theorem, which stated that if line M is parallel to line N, then angle 1 and angle 7 are congruent. And not just angle 1 and 7, but all alternate exterior angles. So, for example, angle 2 and angle 8 in this diagram will be congruent as well. And because the converse of that theorem is also true, we can also say that if angle 1 and angle 7 are congruent, then line M and line N are in fact parallel. Now we're going to talk about one more pair of angles that is formed when two lines are cut by a transversal. First, I want to talk about what it means to be consecutive when we're talking about angles in this situation. Consecutive angles are simply angles that are on the same side of the transversal. So technically, corresponding angles are consecutive angles. Remember, the transversal is the line that cuts or crosses the two lines. Also, from the previous lesson, let's just review the 4 angles of the 8 angles that are formed. The 4 angles on the inside of the two lines are interior angles, so angles 1, 2, 3, and 4 in this diagram are interior angles. Angles of the 8 angles formed that are on the outside of the two lines being crossed by the transversal. So in this case, angle 7, angles 8, angle 5, and angle 6 are all exterior angles. They're on the exterior of the two lines. So now, using our two vocabulary words, consecutive and interior, I can talk about another pair of angles. When two lines are crossed by a transversal, the pairs of angles that are on the same side of the transversal, so consecutive, but inside the two lines, interior, are called consecutive interior angles. And those are shown in the diagram right there, the two blue angles are consecutive interior. And if you guessed that there was a theorem for this angle pair, you'd be correct. However, it is slightly different. If two parallel lines are crossed by a transversal, then the pairs of consecutive interior angles formed are supplementary, which means that their measures add to 180 degrees. Consecutive interior angles are not congruent. So that is a big difference between alternate interior angles and alternate exterior angles. It's also different than vertical angles. It's also different than corresponding angles. So consecutive interior angles are supplementary. Their measures add to 180 degrees. Now the converse of that statement is also true, that if two consecutive interior angles happen to add to 180 degrees, we can say that the two lines that are cut by the transversal are congruent. Right now we're just going to prove the original statement of the theorem. We're going to prove that if the two lines are parallel, then the angles add to 180 degrees. So first, are supplementary. So first, we need to say those two lines are parallel, and that's given to us. Next, because those two lines are parallel, angles 1 and angle 3 form a linear pair, and angle 2 and angle 4 form a linear pair. So if we look at the diagram, angles 1 and 3 are a linear pair, and angles 2 and 4 are a linear pair as well. Now, because angles 1 and 3 are a linear pair, they're supplementary, meaning that the measure of angle 1 plus the measure of angle 3 is 180 degrees. And the same for the measure of angle 2 and the measure of angle 4. That is also 180 degrees. Also, we can say that angle 1 is congruent to 5, and angle 2 is congruent to angle 6 because of the corresponding angles theorem. So angle 1 and angle 4 are congruent, and angle 2 and angle 6 are congruent because of the corresponding angles theorem. Now, because angle 1 is congruent to angle 5, in my first sentence from step 3, the measure of angle 1 plus the measure of angle 3 is equal to 180 degrees. I know that's true. Because the measure of angle 1 is congruent to the measure of angle 5, I can substitute the measure of angle 5 in for that sentence. Therefore, I can have the sentence measure of angle 5 plus the measure of angle 3 equals 180 degrees by substitution. So therefore, I know that the measure of angle 3 and the measure of angle 5 are supplementary. And by the same method, because angle 2 is congruent to angle 6, then I know that instead of the measure of angle 2 here, I can substitute the measure of angle 6, and I get the statement, the measure of angle 6 plus the measure of angle 4 equals 180 degrees, and therefore I know that the measure of angle 4 and angle 6 are supplementary. Therefore, consecutive interior angles are supplementary if and only if the two lines cut by the transversal are parallel. And that's all for this lesson. Thanks for watching. If you don't understand something, please make sure you go back through the video and try to understand it as best as possible. Please take some good notes as you go through, review your notes, try your assignments, And if you have questions, please bring them to live class where we can discuss it more and help you out wherever you need it. If you do need more help, feel free to reach out to us by phone, text, or email. Or, of course, you can always come to the Math Cafe.